Hello, hello, hello. Hello, everyone. A very good morning, all of you, and a very warm welcome to you all to this beautiful session for ISRO 2023. As you all know, ISRO is going to be a golden opportunity for all the mechanical engineers. So that is why this session is planned. Hi Rakshit, welcome. Good morning. How are you all? Please guys do join me fast because we are going to cover the first law, second law, as well as the concept of entropy in this particular session. So the session is going to be very beneficial because we are going to have the revision of the important formula, important concept. Along with that, we will be having some question practice. So first of all, please guys do let me know if my audio and visual quality are fine or not. Hi Abhi, Vinod, Namaskar, Adab, Suprabhat, good morning, Sat Sri Akal, Assalamu Alaikum, Vanakkam. Please get yourself settled down fast and please make some noise so that other students can also join us and get benefited. Thank you, Rakshit. Yes, I will try my level best to cover all the important parts. Provided you should communicate with me, you should have your full dedication, you should have your full motivation and energy. That is what motivates me to bring the session in the most simple, most fruitful manner. All right. Shall we guys start? Are you ready to explore the beauty of thermodynamics? Please do not forget to like and share this session so it reaches to all the other friends of yours, colleagues who are aspiring to crack the ISRO 2023 examination, which is round the corner. So before I start my session, let me quickly introduce myself. This is my quick introduction. My name is Chandrasekhar. I am having more than 10 years of exclusive experience into teaching, guiding the students who are preparing for various competitive examination. I am mechanical engineering graduate from IIT Delhi. पापा का पगले सन. Okay, so पापा की परी का जवाब. So I have done my graduation from IIT Delhi. I have also cleared the engineering services examination which is conducted by UPSC. I am having an experience of more than 2 years working in Steel Authority of India Limited, as well as I am having a vast experience of more than 2 years in a private consulting firm. Hi mechanical engineer, welcome. Please get yourself settled down fast guys. Sit back, relax and enjoy the beauty of this session. My favorite subjects of mechanical engineering are fluid mechanics, thermal engineering, which is thermodynamics and its application, heat transfer, as well as the industrial engineering. If you have any doubt in any of the subjects, hi others, definitely we will be going to have the mock test. Are you talking about the ISRO? We had conducted mock test previously and we will be going to conduct very soon. So stay tuned with us. Do join our Telegram channel. Once you become part of our Telegram channel, then you will be getting the notification of all our important sessions which we are planning for your benefit. All right. So, and I will share the PDF of this session also to my Telegram channel only. Shall we start? So this session is the part of ISRO 2023 crash course where we will be focusing not only the numerical practice, not only the formula revision, but it is the combination of revision of the important formula and concept along with the practicing of some very important, very beautiful questions as well. So the sessions are going to be conducted on Monday, Wednesday and Friday for technical, and Saturday and Sunday are for आदर्श. जो मैंने लिखे हुए हैं वही इंपॉर्टेंट टॉपिक है. फर्स्ट लॉ इज वेरी वेरी इंपॉर्टेंट, सेकेंड लॉ इज वेरी इंपॉर्टेंट एंड एंट्रोपी इज वेरी इंपॉर्टेंट. लेट मी टेल यू वेरी ऑनेस्टली that ISRO is more focusing on thermal engineering part. The highest weightage carrying subject in ISRO is going to be thermal only, more than production, more than any other subject. So you should prepare the thermal engineering basic thermodynamics along with its application thoroughly to clear the ISRO examination. Right? गेट का भी मॉक टेस्ट चाहिए. यस, वॉट एवर इज योर रिक्वायरमेंट प्लीज डू शेयर विद अस. वी विल डेफिनेटली प्लान सम सेशन बेस्ड ऑन योर रिक्वायरमेंट. वी आर देयर टू हेल्प यू आउट in every possible way. So many students have previously asked us to bring the MSQ series. Because of the inclusion of MSQs in GATE examination recently, students are afraid of attempting those MSQ type questions because more than one option is correct. So students are afraid, students have fear. To make them comfortable with the MSQ type of questions, we are planning, or we have already planned, a series for MSQs. Right? So the series has already been started from 8th of August. This is the schedule. You can take the screenshot, or we will be going to share the schedule with you through the Telegram. ये तो केयरलेसनेस है. क्या कह रहे हैं पापा के पगले? मोबाइल बैटरी लो है. आगे क्या लिखा आपने? करंट नहीं आया है. अच्छा, okay, so you will not be able to attend this session. Those who are not able to attend the session live can watch the recording. I will share the link of this session to my Telegram channel. All right, so this is the schedule. Tomorrow I will be having a session on heat transfer, and on 12th of August again I will be having a MSQ session on complete fluid mechanics. So shall we start, guys? Are you all ready? Please make some noise so that we can start. So I will first talk about the theoretical portion, and then we will have some numerical discussion, then again some more theory, and then numerical, again some more concept, and then numerical. This is how I will be going to deliver this session. I hope you will be comfortable with that. All right. So what exactly is the first law of thermodynamics? The first law of thermodynamics was given by Joule. According to Joule's experimental observation, based on the Joule's experimental observation, the first law is defined. Just hold on. Yes, so the first law is also known as Joule's law. What do you know about first law of thermodynamics, everybody? Please give me your opinion. Yes, what do you know about first law of thermodynamics? The first law of thermodynamics is also known as Joule's law. It is also called as energy conservation law. It is also known as quantitative law. Why it is called as quantitative law? It talks about the conservation of energy. It is also called as quantitative law. Yes, because it gives us the information about the quantity of energy which can neither be created nor be destroyed. So energy conservation takes place quantity wise. So that is the first law of thermodynamics. So according to first law of thermodynamics, it is very simple. Whenever there is a system, whenever we are having a system and there is some energy entering into the system, there is some energy leaving from the system. So according to energy conservation, we can say amount of energy entering into the system minus amount of energy leaving from the system is equal to change in energy of the whole system. Can we call the first law, or can we define the first law like this? Hi Nikita, welcome. Good morning. Welcome guys, those who are those who have joined me late, I welcome you all once again from the bottom of my heart to this session. So the total energy transfer, this is called as energy transfer. The total amount of energy transfer will be equal to change in energy of the system. And how the energy transfer takes place? The energy transfer between the system and surrounding takes place in three ways. Can you just let me know what are the three ways through which energy transfer takes place? The energy transfer can take place in the form of heat. The energy transfer can take place in the form of work. Or what is the third? What is the third parameter? The energy transfer can take place along with the mass transfer. The energy transfer takes place along with the mass transfer. If there is a mass entering into the system, it will carrying some energy into the system. Whenever some mass is leaving from the system, it will carry the energy from the system. So the energy transfer can take place in three ways. If the system is a closed system, can you just let me know what is a closed system? So this is the fundamental expression for energy conservation. I hope everyone are aware, everyone knows about it. Which is a boundary phenomena? Heat and work are boundary phenomena. Why they are called as boundary phenomena? Because the energy can be defined in two ways. Listen very carefully, every one of you. The energy can be defined in two ways. One is the transfer of energy, another is the energy content of the system. So energy content of the system is the property like internal energy, like enthalpy. They are called as energy content of the system, which is the property of the system. But energy, there is some portion of energy which is always in transition, traveling from system to surrounding or surrounding to the system. That is known as transfer of energy. So transfer of energy cannot be in the form of internal energy. Transfer of energy cannot be in the form of enthalpy. Transfer of energy can either be in the form of heat or in the form of work. So whenever the transfer of energy takes place due to temperature difference, whenever the transfer of energy takes place due to temperature difference, high temperature to low temperature, then that energy is considered as heat. And all the other forms of energy transfer, like an electrical energy transfer, nuclear energy transfer, chemical energy transfer, mechanical energy transfer, they will be treated as work transfer for the thermodynamic system. So energy transfer is a boundary phenomena, but energy content of the system is not any phenomena. It is the property of the system. So left hand side of the expression in energy transfer and the right hand side of the expression is the energy content of the system. Are you getting it? So if it is a closed system, if the system is a closed system, what is the meaning of closed system? Anybody having any idea what is the closed system? In case of closed system, there is no mass transfer taking place. There is no mass transfer taking place, neither from the system to the surrounding nor from the surrounding to the system. Closed system is no mass transfer, only energy transfer. Only energy transfer, isn't it? So energy transfer can either be in the form of heat and work. These are the two ways of transferring the energy. There is no mass transfer, so energy transfer will take place. So can we say our first law of thermodynamics, delta E for the system. So can we say this is Q minus W? The energy transfer is either in the form of heat. This is a, let us say, closed system. There is some energy entering into the system, that is in the form of heat, let us say. Energy leaving from the system is in the form of work, let us say. All right. So energy entering into the system is in the form of heat and energy leaving from the system is in the form of work. So can we write it as, and delta E, change in energy of a closed system is equal to, or energy of a closed system is sum of, so energy of a closed system is defined as, closed system is equal to sum of internal energy plus potential energy plus kinetic energy. For a closed system, the energy content is sum of internal energy, potential energy and kinetic energy. So can we write our first law of thermodynamics for a closed system to be Q minus W is equal to delta U plus delta potential energy plus delta kinetic energy? Do you guys agree or not? And one more thing I wanted to highlight here. Whenever there is energy transfer taking place from the system to the surrounding or from the surrounding to the system, because the energy is in transition. So that is why the sign conventions are required for energy transfer. Whenever the energy transfer takes place, we always define or we always have the sign convention. So the general sign convention is when the heat is added to the system, it will be taken as positive. When the heat is rejected from the system, it will be taken as negative. Similarly, when the work is done by the system, then it will be taken as positive. Whenever the work is done on the system, it will be taken as negative. So this is the expression if the closed system is stationary. That is for a closed system. This is the first law of thermodynamics for a closed system. If it is a stationary system, if it's a stationary closed system, if it is a stationary system, what does that mean? There is no change in potential energy. There is no change in kinetic energy. It will be zero. So Q minus W is equal to delta U is our expression for first law of thermodynamics for a closed stationary system. This is the first law of thermodynamics for our closed and stationary system. Do you guys agree with it? Is this clear to everyone? So whether the closed system is undergoing a reversible process or irreversible process, it does not matter. For the energy conservation, for the conservation of energy, reversibility of a process or irreversibility of process has nothing to do, because energy conservation is a universal concept or universal law. So whether the process undergone by the system is a reversible or irreversible, the same expression will be used. I hope this is clear. If anybody is having anything to ask, you can just let me know. Is this clear? Now, if the closed system is undergoing a thermodynamic cycle, if the closed system is undergoing a thermodynamic cycle, what will be the expression for? If the closed system is undergoing a thermodynamic cycle, what will be the expression for? So first law defines, we can say, the first law of thermodynamics defines the energy of the system. Energy of system. And according to this energy of the system, energy is a conserved property. What first law tells us is energy is a conserved property of the system. Property of system. It is the property of the system. Energy is a conserved property of the system. It means it does not depend on the path. Not depend on process path. Energy does not depend on the process path, whether the process is reversible or irreversible. So energy of a system is a conserved property. If we apply the first law of thermodynamics for a closed system undergoing a thermodynamic cycle, for a thermodynamic cycle, change in property will be zero, isn't it? If it is a thermodynamic cycle, change in property will be zero. Do you agree? So change in, for a thermodynamic cycle, change in property will be equal to zero, because for a thermodynamic cycle, initial and final states are same. So first law of thermodynamics can be written as E in is equal to E out. Why? Because change in energy of the system will be equal to zero. So energy entering will be equal to energy leaving from the system. and energy entering is taking place in the form of heat transfer, energy leaving from the system is taking place in the work transfer. So we can say Q net is equal to W net, or we can say cyclic integration of del Q is equal to cyclic integration of del W. These are the various ways of writing the first law of thermodynamics for a thermodynamic cycle. This is how we can write the first law of thermodynamics for a cycle. And this equation is valid only for a cycle. Whether it is reversible or irreversible, it does not matter. And this is the equation Q minus W is equal to delta U, that is applied for a closed system undergoing a process. Closed system undergoing a process. Closed system undergoing a process, whether the process is reversible or irreversible. Or we could have written it as Q is equal to delta U plus W, one and the same thing. So this is the expression for a closed stationary system undergoing a thermodynamic process, and this equation is valid for a closed system undergoing a thermodynamic cycle. Yes, as long as the bottle is closed, others, as long as the bottle is closed, whenever there is no mass transfer taking place, if the bottle is open, then the mass transfer will take place in terms of steam. The steam will evaporate from the system, then it will become open system. But as long as the cap is closed or the ढक्कन is closed, then the steam will not go out. Steam will not go out of the system, so that is why it is a closed system. Closed system and open system are only defined with respect to the mass transfer. It has nothing to do with the energy transfer. Closed or open system are defined only with respect to the mass transfer taking place across the system boundary. I hope this is clear. Can we proceed further? Yes, there is a question now. There is a question on your screen. I want everyone to respond for this question. Solve this one. And if you have any doubt, please do let me know. I am here to help you out in any of the confusions. So stay with me till the end of the session. We will completely cover with your full satisfaction the first law, second law, as well as the entropy. Entropy is complicated concept, so we will try to cover the entropy as well. Once you become comfortable with first law, second law and entropy, then the application of the thermodynamics will also become clear to you. Yes, waiting for your answer. Heat added to the system. I told you the sign convention heat. If it is added to the system, it is taken as positive. It is rejected by the system, it is taken as negative. Similarly, heat is denoted by Q. Similarly, work, when it is done by the system, because we are assuming Q is entering into the system, so that is why it is positive, and W is leaving from the system. That is why Q minus W is the energy transfer. So that is why W is taken as positive. So Q minus W. We are writing E in minus E out, and that is why we are writing Q minus W. That is the basis of this sign convention, nothing else. Otherwise, you can just take it as energy. So energy transfer is energy entering minus energy leaving will give rise to change in energy of the system. What is the answer? Work done by the system is taken as positive, and work done on the system is taken as negative. It is a process. A gas contained in a cylinder is compressed. It is a compression process, and compression happens in a system only when there is a work done on the system. The compression of the system will take place only when the work is done on the system. Expansion. So we can say done by the system. Expansion work is positive because done by the system, and compression work is negative. Why? Because it is done on the system. Expansion work is positive because the work is done by the system for expanding the gas, and compression work is negative because the work is done on the system to compress the gas. So a gas in a gas contained in a cylinder is compressed. The work required for compression is 5000 kilojoule. Can we say W is equal to minus 5000 kilojoule? Please give me yes. During the process, heat interaction of 2000 kilojoule. During the process, heat interaction of 2000 kilojoule causes the surrounding to be heated. It is to be heated. It causes the surrounding to be heated. When the surrounding gets heated, when the heat is rejected to the surrounding, isn't it? When the heat is rejected by the system to the surrounding. So do you agree Q is also minus 2000? W and Q both will be negative. Then the change in internal energy of the system during this process, if we write the first law of thermodynamics, then Q minus W is equal to delta U. What is Q? Put the value along with sign. What is W? Put the value along with sign. Is equal to delta U. Delta U is U2 minus U1, final internal energy minus initial internal energy. So minus 2000 plus 5000 will be the correct answer. Minus 2000 plus 5000. What is the answer to the question? Is it 7000 or 3000? Isn't it 3000? Why you guys are committing mistake? Chintu, others, Paglesan, why you guys are committing the mistake? One incorrect sign convention will definitely destroy your whole fundamentals. It will definitely shatter your fundamentals. So take care of the sign of heat transfer and work transfer. So the correct answer is option number C. It will be plus 3000. I hope this is clear. Let us move to the next one. Now I want everyone to give me the correct answer. Please do give me the right answer for this one. Give me the correct answer for this one. It is your turn. The more you practice on your own, the more confident you become. And the game is all about the confidence level. If you are confident enough to clear the examination, 70%, 60 to 70% of the job is already done. But if you are afraid of clear the examination, then definitely you will perform badly. So to develop the confidence, you should start writing on a piece of paper. Even if you are getting the incorrect answer, it does not matter. So the answer to this question, every one of you, please give it a try. Yes, Paglesan, good, good, good. Mechanical engineer. In an adiabatic process, what is adiabatic process? Heat transfer is equal to 0. 5000 joule of work is performed on a system. The work is performed on a system in an adiabatic process. Let me call it adiabatic process as 1. This is the adiabatic process 1. 5000 joule of work is performed on the system. It means work is done on the system. W1 is equal to minus 5000 joule. Isn't it? It will be negative. Work done on the system is negative. The system returns to its original state. What is the meaning of this? It means the system is undergoing a thermodynamic cycle. When the initial and final state of the system becomes same, it will be a thermodynamic cycle. So during this, it is returning. So it was the initial state. There is a process 1. And then the system is returning back to its original state through another process. Let me call it as 2. So Q1 is equal to 0. First one is adiabatic process, but Q2 is not equal to 0. So initial and final state are same. Then we can call it as thermodynamic cycle. While 100,000 joule of heat is added to the system returns to its original state by 1000 joule. So Q2 is equal to plus 1000. The work done during the non-adiabatic process will be how much? So first law, if we apply for a cycle, then we can say energy entering is equal to energy leaving, or we can say net heat transfer is equal to net work transfer. Net heat transfer will be equal to net work transfer in a thermodynamic cycle. So the heat transfer, total heat transfer Q1 plus Q2 is equal to W1 plus W2. This will be the expression. Q1 plus Q2 is equal to W1 plus W2. So Q1 is 0 plus what is Q2? Q2 is plus 1000 is equal to W1. W1 is minus 5000 plus W2. So you can easily find out the value of W2. Put the values with their signs properly, then you will get the answer. What is the answer, Vinod? Is it B or C? Again you are committing. What is the answer? Is it B or C? That is where you guys are committing mistakes. Do not repeat the mistake. Even if you commit the mistake once, it is acceptable. Even if you commit the mistake twice, it is a learning. It is an alarm sign. But if you are repeating the same mistake third time, then you should pay for it. So it will be plus of 6000. C will be the right answer. Well done, guys. Well done. I hope this much portion is clear to everyone. I hope this is clear to everyone of you. Any doubt so far? Now let us try to observe the flow process. What is the meaning of flow process? When the mass flow takes place across the boundary of the system. So such a system is called as open system. Such a system is called as open system. In open system, there is a mass transfer taking place. So if we talk about the first law of thermodynamics for an open system, according to mass conservation, can we say mass entering minus mass leaving is equal to change in mass of the control volume? The analysis of the open system is done using the control volume approach. Control volume. Open systems are analyzed by using the concept of control approach. This is a system, let us say. Open system. Then there is a mass entering. There is a mass leaving. So according to mass conservation, whatever the amount of mass entering minus amount of mass leaving from the system is equal to change in mass in the control volume. Do you agree? Simple. Like energy conservation, mass conservation is also a fundamental concept or universal concept. Mass conservation and energy conservation are universal laws. So if we write per unit time, so we can say m dot I entering, I for inlet, minus m dot E for exit, is equal to m dot, that is the mass flow rate, is equal to dm by dt in the control volume. The unit is kilogram per second. The unit is, if we write per unit time, then the expression will be m dot I minus m dot E is equal to dm by dt. Do you agree? That is the simple mass conservation per unit time. Now if we talk about the energy conservation for a flow process, if we talk about energy conservation, so we can say again energy in entering minus energy leaving is equal to change in energy in the control volume, is equal to change in energy in the control volume. So this is energy transfer. It will be taking place with the heat transfer. It will be taking place with the work transfer, and it will be taking place along with the mass transfer as well. The left hand side will have three parameters: Q, W, as well as the mass transfer, isn't it? If the process is a steady flow process, if the process is a steady flow process, do you know what is a steady flow process? Anybody is having any idea about a steady flow process? Quickly, do let me know. What do you understand by the steady flow process? If it is a steady flow process, it means the properties do not change with time. Properties do not change with time, and mass is a property of the system. So we can say it means dm by dt is equal to 0. change in mass with time is equal to 0. So the mass conservation equation will become m dot I is equal to m dot E is equal to constant, which can be called as m dot. In case of steady flow process, the mass is entering at section 1 and the leaving at section 2. This is our control volume. If mass is entering at section 1 and leaving at section 2, so we can say mass flow rate is rho 1 A1 C1 is equal to rho 2 A2 C2 is equal to constant. What is mass flow rate? Rho AV. C is the velocity because V is used for, or we can say A1 V, A1 C1, A1 into C1 by V1 is equal to A2 C2 by V2 remains constant. That is our mass conservation. What is C here? What is C in this case? C is called as velocity of flow. Velocity of the flow of the fluid. C1 and C2 are at inlet and outlet. Similarly, rho is the density, A is the area, flow area. A is the flow area. Flow area at inlet is A1, at outlet it is A2. And V is the specific volume. V is the specific volume which is reciprocal of density. So at inlet it is V1, at outlet it is V2. V is the specific volume which is the reciprocal of density, right? So that is the mass conservation for a steady flow process. If we talk about the energy conservation for the steady flow process, if we write the energy conservation equation for the steady flow process, then we can say in case of steady flow process, the internal energy will be replaced by enthalpy. The internal energy is replaced by enthalpy. The internal energy will be replaced by enthalpy, right? So our expression will be for the steady flow process, we can say our expression for energy conservation will be Q minus W is equal to delta H plus delta potential energy plus delta kinetic energy. This is the energy conservation equation for the steady flow process. This is the energy conservation equation for the steady flow process. Are you getting it? And if we write per unit time, if we write per unit time, if we write it as per unit time, then how we are getting this? Because if we write it as per unit time, then we will get H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. This is the expression per unit time. This is called as steady flow energy equation. This is the expression called as steady flow energy equation. The unit of each and every term is joule per kg. H is the enthalpy. What is H? Specific enthalpy. That is U plus PV. PV is called as flow energy. This is called as flow energy. So for a steady flow process, the expression will be given by steady flow energy equation. I hope this is clear. Isn't it? अगर किसी को डाउट है ये एक्सप्रेशन आया कहां से, I can explain. In the left hand side there is a heat transfer, there is a work transfer, there is an energy transfer along with the mass transfer. In the right hand side, change in energy of the control volume. From this we will develop that internal energy will be replaced by enthalpy in case of steady flow process. So steady flow energy equation is used for all the steady flow devices. For all the steady flow devices. What are the steady flow devices? What are the devices we use in our thermodynamic cycle? Like a compressor or turbine. Turbine is a work producing device, compressor is a work consuming device, or it can be heat exchanger like condenser or boiler, evaporator, or it can be correct for nozzle, diffuser. All are steady flow, all are treated as Steady flow devices. Why they are called as steady flow devices? Because they are operating in a particular environment for longer duration. So mixing chamber is also treated as steady flow device. Mixing chamber. So these are some of the steady flow device. Throttling device or throttling valve can also be treated as steady flow device. So these are some of the steady flow devices where we apply the first law of thermodynamics, which is called as steady flow energy equation. H1 plus C1 square by 2 plus GZ1 plus Q heat transfer is equal to H2 plus C2 square by 2 plus GZ2 plus W. 1 is for inlet, 2 is for outlet. 1 is for inlet or entry and 2 is for outlet from the control volume or exit. Point 1, and the unit of each and every term is joule per kg. It is joule per kg. इमरान, ये तो मुजफ्फरपुर ही बताएगा। किसमें रैंक की बात कर रहे हैं? आपके गेट की रैंक की बता रहे हैं क्या? ये कहां में रैंक आया? ये एनर्जी पर यूनिट मास है, क्योंकि ऑल आर स्पेसिफिक पैरामीटर्स, एनर्जी पर यूनिट मास. But do not forget to put all the parameter in their SI unit. All the parameter must be used in SI unit. For an example, C should be taken as meter per second. H should be taken as joule per kg. G is taken as meter per second square. Z is taken in meter. Q and W should be taken in joule per kg. Q and W should be taken in joule per kg. Put all the parameter in their SI unit, then only you will get the answer in SI unit. There is a question on the screen. There is a question on the screen. Please try to solve this one. Find out the answer to this question. Everyone, please give it a try quickly. What is the answer to this question? A small steam vessel, it is perfectly insulated. What is the meaning of insulated? It is thermally insulated, so Q is equal to 0. And doing no shaft work, it means W is equal to 0. Causes a drop of this much energy. Energy means enthalpy. Because it is a steady flow device, so it is causing a drop. H1 minus H2 is equal to 0.8 kilojoule per kg. H1 minus H2. The kinetic energy of the stream at entry is negligible. It means C1 is 0. The velocity of the stream at exit. We need to find out the value of C2. Can you find out this value of C2? H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. C1 is 0. There is no change in potential energy. Q is equal to 0. W is equal to 0. So can we say C2 is equal to 2 H1 minus H2 under root? Put the value in their SI unit. Do not forget to put the value in their SI unit. So 0.8 kilojoule per kg will become 800 joule per kg. So C2 will be equal to under root of 2 into 800. That will give you meter per second, isn't it? So it is 40 meter per second will be the value of C2. The answer will be 40 meter per second. The answer will be 40 meter per second. I hope this is clear. Is this clear to everyone? Now let us move to the unsteady flow process. Unsteady flow process means change in mass in control volume is not 0. Unsteady flow process. For unsteady flow process, there is mass entering, there is mass leaving, and there is some process undergoing by the system. 1 to 2. There is a process 1 to 2 undergoing by the system. 1 is the initial state and 2 is the final state. The state does not remain same with time. The state will remain, the properties will not remain same with respect to time. If the flow process is unsteady, so property changes with time. Changes with time. So according to mass conservation, we can say Mi minus Me is equal to M2 minus M1 in the control volume. That is our mass conservation. Mi minus Me is equal to change in mass in the control volume. I for inlet or entry to the control volume, E for exit or outlet. 1 is the initial state of the system, 2 is the final state. This is the mass conservation equation. Mi minus Me is equal to M2 minus M1 in the control volume. So if the system is initially evacuated, it means M1 is equal to 0. If the system is initially vacuum, if the system is initially empty, then M1 will be equal to 0. If the system is finally evacuated, then M2 will be 0. Please do understand. If the system is initially evacuated, then M1 is equal to 0. And if the system is finally evacuated, then M2 will be 0. If there is no mass entering into the system, then Mi will be 0. If there is no mass leaving from the system, then Me will be 0. There are 4 different situations. Accordingly, we will put 0 whatever is applicable to. Clear? If there is no mass entering into the system, Mi will be 0. If there is no mass leaving from the system, Me will be 0. If the system is initially evacuated, then M1 is equal to 0. If the system is finally evacuated, then M2 will be equal to 0. If we write the energy conservation equation for unsteady flow process, so there is the heat transfer 1 to 2. Let me call it as heat transfer. Heat transfer to the system, work transfer from the system. This is I, inlet. This is exit, outlet. So there are 4 parameters, 4 points, I, E, 1 and 2. So heat is added to the system, work is done by the system. So according to the first law of thermodynamics or energy conservation equation, try to understand. So it will be Q plus Mi. The energy conservation equation will be Q plus Mi Hi minus, this is E in, minus W plus MEHE, this is E out, is equal to M2U2 minus M1U1 in the control volume. That is the change in energy of the system. This is our first law of thermodynamics for an open system undergoing unsteady flow process. The unit of each and every term is joule or kilojoule. The SI unit will be joule, and small u is the specific internal energy and small h is the specific enthalpy. It means joule per kg. Joule per kg. Do you understand this expression? This is our energy conservation equation for the unsteady flow process. That completes our first law of thermodynamics. I hope this is clear to everyone. Now let us move to the second law of thermodynamics. What do you understand by the second law of thermodynamics? What do you understand by the second law of thermodynamics? Every one of you, please do let me know. Second law of thermodynamics is also called as qualitative law. Second law of thermodynamics is called as qualitative law because the second law of thermodynamics talks about the quality of the energy. The quality of energy is not conserved. It is the quantity of energy which is conserved. So first law of thermodynamics is called as quantitative law because it is talking about the quantity of energy which is always conserved, whereas the second law of thermodynamics talks about the quality of energy which is not conserved. That is why it is quality means whether the energy is having disorganized form or organized form. For an example, heat is called as low quality energy. Q is energy of low quality because it cannot be converted into useful work easily, whereas W is called as energy of high quality. Heat is called as energy of low quality and work is called as energy of high quality. It is also known as directional law. Second law of thermodynamics is also known as directional law. Why it is called as directional law? Because the second law of thermodynamics gives the direction to a particular process through the concept of entropy. Second law of thermodynamics gives the concept of entropy. First law of thermodynamics gives the concept of energy. First law is about the energy, whereas the second law of thermodynamics is talking about the entropy, which is the degree of randomness or disorderness existing in a system. Entropy. If the entropy increases, it means quality will decrease. Quality or decreases, or we can say efficiency of the system decreases. When entropy increases, quality will decrease or efficiency will also decrease. So it is always the need of the hour is to conserve the high quality energy. Whenever we talk about the energy conservation, the high quality energy need to be conserved rather than low quality energy. Low quality energy is not useful. The energy which is useful is of higher quality. So the higher quality energy need to be conserved, like electricity. Electricity is the energy of high quality, which can be easily converted into our useful form. So these need to be conserved. So entropy, we can say it is again a property, but it is non-conserved property. Energy is a conserved property, but entropy is a non-conserved property. Why entropy is a non-conserved property? Because entropy can be created. Entropy can be created or entropy can be generated. That is known as entropy generation. And how the entropy gets generated? Can anybody let me know how the entropy gets generated? The entropy gets generated due to irreversibility associated with a process. The entropy gets generated due to irreversibility associated with any process. I hope this is clear. So entropy we will talk about later on, but let us first focus on the second law of thermodynamics, which is called as qualitative law or which can also be called as directional law. So the second law of thermodynamics is the combination of two parallel statements. The second law of thermodynamics is a combination of two statements. One is called as Kelvin-Planck statement and another is called as Clausius statement. Kelvin-Planck statement gives the concept of heat engine, whereas the Clausius statement gives the concept of heat pump and refrigerator. Right? So what is Kelvin-Planck statement of second law of thermodynamics? According to Kelvin-Planck statement, it is impossible to construct a cyclic device. It is impossible to develop a cyclic device which produces work while exchanging heat with a single reservoir only. That is called as PMM2. Perpetual motion machine of second kind is impossible. That is the concept of Kelvin Planck statement. When we supply heat and there is a thermodynamic cycle, let us say, the system is undergoing a thermodynamic cycle, so it cannot produce work completely. So work produced should not be equal to Q. That is our PMM2. PMM2 is the machine which produces work while exchanging the heat only with a single reservoir. So it is impossible. W should always be less than Q. It cannot be equal. W should always be less than Q. That is our Kelvin Planck statement. Work produced should always be less than heat supplied to the thermodynamic cycle. So it gives the concept of heat engine. So what the heat engine involves? It involves two thermal reservoirs. It requires two thermal reservoirs. One is source which supply heat, another is sink which gets the heat, and the working fluid. There must be two thermal reservoir and a working fluid which is undergoing a thermodynamic cycle. Thermodynamic cycle. Which is undergoing a thermodynamic cycle. Isn't it? So heat engine looks like this. It is a work producing cyclic device. Heat engine is a work producing cyclic device. It is clockwise cycle. And there are steady flow devices 1, 2, 3 and 4. There are 4 cyclic devices, steady flow devices. There are steady flow devices where the working fluid is undergoing a cycle. One is a compressor. 2 is evaporator or boiler. Evaporator which gets the heat Q1 from the source. This is source which is giving the heat to our system. This is our system which is a clockwise cycle. And then 3, the third device is a turbine which produces work, and the 4th one is condenser which releases heat to the sink. Sink is low temperature reservoir, source is the high temperature reservoir. Let me call it as the temperature of the source as T1, temperature of the sink is T2. This is our cyclic device. This is our thermodynamic heat engine. This is a heat engine working on a cyclic device. So we define the thermal efficiency for this. How the thermal efficiency is defined? Thermal efficiency is equal to net work output, the ratio of net work output, that is W net, upon heat input. The ratio of net work output to the heat input. W net by Q is thermal efficiency. This is the thermal efficiency, isn't it? So if we apply the first law of thermodynamics, then we can say, from the first law of thermodynamics, we can say thermal efficiency is equal to net work output upon Q1. And from the first law of thermodynamics, heat added to the system is equal to the heat rejected and the work done, W plus Q2. So W net can be written as Q1 minus Q2. So the thermal efficiency is equal to 1 minus Q2 by Q1, which is less than 100%. This is the expression for thermal efficiency. So either we call it as W net upon Q1, or we can say Q1 minus Q2 upon Q1, or we can call it as 1 minus Q2 by Q1. Q2 is the heat rejected to the sink. This is the expression which is valid for reversible as well as irreversible cycle. It is reversible as well as irreversible engine. This is the expression for thermal efficiency which is valid for reversible and irreversible. So if all the processes are reversible, then we call it as Carnot thermodynamic cycle. So it is completely reversible cycle. What is the thermal efficiency of this cycle? Completely reversible. It is the completely reversible cycle. It is the completely reversible cycle, Carnot cycle. All are reversible process. All the processes are reversible processes, which is practically impossible. Carnot cycle is practically impossible. What is the thermal efficiency of Carnot cycle? Can anybody let me know? What will be the thermal efficiency of Carnot cycle? So in case of Carnot cycle, we can say Q1 by T1 is equal to Q2 by T2. That is called as thermodynamic temperature scale. So if we write this way, then the thermal efficiency of a reversible cycle is equal to 1 minus T2 by T1, or we can say T1 minus T2 upon T1. That is for a Carnot cycle. Thermal efficiency of Carnot cycle, which is maximum. It is having the maximum efficiency, but it is not 100%. Do not think that it is 100%. No engine can have efficiency 100%. T2 is the sink temperature here. Lower temperature reservoir. Low temperature reservoir. And T1 is the source temperature. High temperature reservoir. So this is the expression for thermal efficiency for the Carnot cycle. So when the cycle is reversible, then we use this expression. For irreversible cycle, we can use the general expression. Can you solve this one, this question, everyone? Please give it a try. What is the answer? A cyclic heat engine does 50 kilojoule of work per cycle. This is the work produced. If the efficiency of the heat engine is 75% or thermal efficiency is 0.75, the heat rejected per cycle, Q2. If we draw, this is Q1, heat added to the heat engine. Then there is a heat rejected and work is done. So if we talk about the first law of thermodynamics, so the question is to find out Q2, W is given as 50 kilojoule. So thermal efficiency can be written as W by Q1. So we can say Q1 is equal to W by thermal efficiency. What is W? W is 50 upon 0.75. That is Q1. But the question is to find out Q2. So isn't it Q2 is equal to Q1 minus W? Q2 is equal to Q1 minus W. So 50 upon 0.75 minus 50 will give you the answer. So 50 into 1 by 0.75 is 4 by 3 minus 1. So it is 1 by 3. 50 into 1 by 3. 50 by 3. Q2 will be equal to 50 by 3 kilojoule. Q2 will be 50 by 3 kilojoule. What is the answer? Right? So 50 by 3 kilojoule, which is 16 2 by 3 kilojoule, which is 16 2 by 3 kilojoule, isn't it? Is this clear? Let us move further. Then the another statement is called as Clausius statement of second law of thermodynamics. According to Clausius statement of second law of thermodynamics, it is impossible to construct a cyclic device which transfer heat from lower temperature body to higher temperature body without any external work. Heat cannot flow. According to Clausius statement, heat can't flow from low temperature to high temperature. Heat cannot flow from low temperature to high temperature without any external support. So if we want the heat to flow from low temperature to high temperature, there must be a work done. So closest statement of second law of thermodynamics gives the concept of refrigerator and heat pump. It gives the concept of refrigerator as well as the heat pump, right? So what is the refrigerator? Refrigerator is a work consuming cyclic device which maintains the lower temperature. So this is the desired output, desired effect, that is Q2, and this is Q1. This is our source and this is the sink. So work consuming cyclic device which maintains the lower temperature compared to the surrounding. This is the surrounding. This is our cold storage space. So this is the refrigerator. It is work consuming, so anti-clockwise cycle. So here we define coefficient of performance, that is desired output, the ratio of desired output to the work input or net work input. COP, coefficient of performance, is Q2 upon W. Or we can write according to first law of thermodynamics, we can say from the first law of thermodynamics, we can say Q1 is equal to, from the first law we can say Q1 is equal to Q2 plus W. So COP for a refrigerator is given by, which is Q2 by W, or we can write Q2 upon Q1 minus Q2, which can be less than, greater than 1, which can be less than, equal to, less than, or it can be equal to 1 or greater than 1. As the coefficient of performance increases, the thermal performance increases, running cost decreases. So more is the coefficient of performance, less will be the running cost, isn't it? So this is about the refrigerator. So refrigeration effect is the value of Q2. There is a term defined that is called as the refrigeration effect. What is the refrigeration effect? The refrigeration effect is the amount of heat to be extracted from the storage space in order to maintain the lower temperature. Q2 is the refrigeration effect. So refrigeration effect, the unit is ton. Sometimes we use ton as the unit. So 1 ton is equal to 3.5 kilojoule per second or 210 kilojoule per minute. That is how we can convert. So Q2 is called as refrigeration effect. Sometimes the question are asked about the refrigeration effect. 3.5 kilojoule per second. It is kilowatt. Or 210 kilojoule per minute. This is the refrigeration effect. Then there is another cyclic device, work consuming cyclic device, which is called as a heat pump. In heat pump, the desired output is maintaining the higher temperature. This is T1, this is T2. So work consuming cyclic device which maintains higher temperature. So the desired output is maintaining the higher temperature Q1. So here COP for the heat pump is equal to, numerator is Q1 upon W, or we can say Q1 upon Q1 minus Q2. This is the expression for COP for the heat pump. No, as long as reversible cycle is not mentioned, we cannot write in terms of temperatures. We cannot write in terms of temperature. So what we need to understand from here, for the same heat transfer, same input and output, for same input and output, we can develop COP for the heat pump is equal to COP for the refrigerator plus 1. So COP for the heat pump is always greater than 1, whereas COP for the refrigerator can be less than, can be equal to, greater than 1. Can be less than or can be greater than 1. For a refrigerator, it can be less than, it can be equal to, it can be greater than 1. But for heat pump, it is always. If it is the reverse Carnot cycle, refrigerator or heat pump, if it is a reverse Carnot cycle, then COP for the refrigerator, which is Q2 by W, or we can say Q2 by Q1 minus Q2. If it is reversible, then COP for reversible refrigerator will be equal to T2 upon T1 minus T2. Similarly, COP for heat pump, that is valid. These expressions are valid for reversible as well as irreversible. COP for the heat pump is given as Q1 by W, or we can say Q1 upon Q1 minus Q2. But if it is a reversible cycle, then COP for the reversible heat pump is equal to T1 upon T1 minus T2. अवेलेबिलिटी तो नहीं हो पाएगा आज, बट एंट्रोपी जरूर कंप्लीट करेंगे. अदर्स फॉर रेफ्रिजरेशन इट कैन बी लेस देन 1, इट कैन बी इक्वल टू, इट कैन बी ग्रेटर देन 1. ऐसा देखिए ना, हाउ टू अंडरस्टैंड दिस. लुक, this is Q1, this is a cyclic device, this is Q2, and this is a work input. So can we say Q1 will be always be greater than W? Q1 will always be greater than W, isn't it? But Q2 can be less than W, can be equal to, can be greater than W. Do you agree or not? Q1 is always greater than W. It cannot be equal as well. It cannot be equal. Q1 is always greater than W, whereas Q2 can be less than, because from the first law of thermodynamics, Q1 is equal to Q2 plus W. Q2 cannot be 0. Q2 cannot be 0. It cannot be 0. Q2 cannot be 0. Otherwise, it will violate the Kelvin-Planck statement. One single reservoir will not develop a cyclic device. So Q2 will never be 0. So Q1 will always be greater than W, and Q2 can be less than W, can be equal to, can be greater than W. So from here we can easily say COP for refrigerator can be less than 1, can be equal to 1, can be greater than 1. But for a heat pump, COP cannot be less than or equal to 1. It will always be greater than 1. I hope this is clear. Isn't it? So if we talk about the thermal efficiency of, we can say for same input and output, for same input and output Q1, T1, T2, Q2 and W, if there are same input and output, then we can say we can say, what we can say, COP for heat pump is equal to 1 upon thermal efficiency of the engine, which is equal to COP for refrigerator plus 1. This is what we can write. For a heat pump, COP is reciprocal of thermal efficiency, and COP for the heat pump is refrigerator COP plus 1. That you should always remember for the same input and outputs. And one more important thing, when the thermal efficiency of actual cycle, when the thermal efficiency of actual cycle is less than thermal efficiency of reversible cycle, then actual cycle is irreversible. If it is equal to thermal efficiency of reversible cycle, then actual cycle is reversible. When it is greater than thermal efficiency of reversible cycle, then actual cycle is impossible. Similarly, COP for actual cycle, if it is less than COP for a reversible cycle, then actual cycle is irreversible. Then actual cycle, if it equal to COP for reversible cycle, then actual cycle is reversible. We are talking about work consuming cycle. If it is greater than COP for a reversible cycle, such a cycle is impossible. We can easily find out whether a particular cycle will be possible or impossible, or whether a cycle is reversible or irreversible based on this condition. Based on this condition, we can define that. Is this clear? There is a question on the screen. Quickly solve this one. A condenser of a refrigeration system rejects heat at the rate of 120 kilowatt. Find out the answer to this one. A condenser of a refrigeration system rejects heat at the rate of 120 kilowatt while its compressor consumes a power of 30 kilowatt. The coefficient of performance of the system. It is the refrigeration system. What is the answer? What will be the answer? Condenser rejects heat at the rate of 120. So condenser rejects heat means Q1 is 120. This is a refrigerator and the compressor is consuming a power of 30. W is equal to 30. So COP, this is Q2. So first of all, for a COP of a refrigerator, we can say Q2 by W because desired output is Q2 to maintain the lower temperature. The objective is to maintain the low temperature. First of all, find out the value of Q2. Can you find out the value of Q2? Q2 will be equal to 90 kilowatt, isn't it? Q2 is equal to Q1 minus W, which is 120 minus 30, that is 90 kilowatt. So Q2 is 90 and W is equal to 30. So the COP will be 3. For COP of the refrigerator will be 3. Another question on your screen. Next question on your screen. Then we will move to entropy. Then after this we will move to entropy. We will try to analyze the concept of entropy quickly. Efficiency of a Carnot engine is 75%. Carnot engine means reversible engine. If the cycle direction is reverse, COP of the reverse Carnot refrigerator is. So I told you COP for the heat pump is equal to 1 upon thermal efficiency is equal to COP for refrigerator plus 1. From here you can write. We need to find out the COP for the refrigerator. 1 upon 0.75 is equal to COP for refrigerator plus 1. So COP for refrigerator is equal to, what is 1 upon 0.75? That is 4 by 3. Minus 1, that is 1 by 3 and that is 0.33, isn't it? C is the answer. 0.33 will be the correct answer. Now to define the entropy, we talk about the Clausius inequality. What is Clausius inequality? As per the Clausius inequality, we can say cyclic integration of del Q by T. We find the cyclic integration of del Q by T, and if it is less than 0, cyclic integration of del Q by T, if it is less than 0, then the cycle will be irreversible. Actual cycle will be irreversible. Is irreversible. And if it is equal to 0, then actual cycle is reversible. If it is greater than 0, then actual cycle is impossible. So cyclic integration of del Q by T for a thermodynamic cycle, it is a cyclic integration that is for thermodynamic cycle. For a thermodynamic cycle, cyclic integration of del Q by T should always be less than 0. For a thermodynamic cycle, cyclic integration of del Q by T should always be less than 0. So del Q by T should always be less than equal to 0 for any cycle. For any thermodynamic cycle, whether it be reversible or irreversible. Isn't it? Clear? Can you let me know the answer to this one? In the case of refrigeration cycle, the expression is valid for a refrigeration or heat pump cycle as well. It is valid for refrigeration cycle, heat pump cycle, as well as heat engine cycle. So in case of refrigeration system undergoing an irreversible process, cyclic integration of del Q by T should always be less than 0. Yes, it should be always be less than 0. Yes, others. Yes, Paglisan. Well done. Good. Then if we talk about the entropy change for an isolated system, do you know what is isolated system? Isolated system is not same as insulated system. Insulated system is having Q is equal to 0, but isolated system is having Q is equal to W is equal to 0. There is neither any heat transfer, work transfer, nor any mass transfer. For an isolated system, heat, work and mass transfer will be 0. Insulated system is only when the heat transfer is 0. So if we talk about the isolated system, it is universe. Universe can be treated as isolated system, that is system plus surrounding. So change in entropy for the isolated system or universe, which is equal to change in entropy for the system plus change in entropy for the surrounding, should be greater than 0. That is called as entropy generation. Should always be greater than 0. Entropy change for the universe should always be greater than 0. Entropy change for the universe should always be greater than 0. This is for isolated system. And then we define the increase of entropy principle. So entropy of universe always increases. What is the entropy principle? Entropy of universe. So entropy is non-conserved property. There is a generation of entropy due to irreversibility. Entropy generation is due to irreversibility. So what we can say, entropy of universe always increases. Entropy of universe always increases. For any process is possible only when entropy of the universe increases, or it can remain constant for a reversible process. For an example, if we talk about change in entropy for the universe, or that is entropy generation, if it is less than 0, entropy change for the universe or entropy generation, that is sum of entropy of system and surrounding. If it is less than 0, then process is impossible. It means impossible process is impossible. If it is less than 0, the process is impossible. If it is equal to 0, the process is reversible. And if it is greater than 0, then the process is irreversible. So that is how the second law of thermodynamics gives the direction to a particular process. That is how the second law of thermodynamics gives the direction to a particular process through the concept of entropy. If the entropy generation is equal to 0, the process undergone by the system is reversible. If the entropy generation is less than 0, such a process is impossible. And if the entropy generation is greater than 0, then the process undergone by the system is irreversible. So that principle is called as entropy, increase of entropy principle. And for the process to happen, it must satisfy the first law as well as the second law. There is a question on the screen. Find out the answer to the given question, everyone. I'll take around 10 more minutes to complete the entropy concept. If you have any doubt in any of the concept discussed so far, Please do let me know through the comment section. A system of 100 kg mass undergoes a process in which its specific entropy increases from 0.3 to 0.4. What is the change in entropy of the system? That is 0.4 minus 0.3. That is equal to 0.1. At the same time, the entropy of surrounding decreases. What is the entropy of the surrounding? Decreases from 80 kilojoule per Kelvin. So this was the specific entropy. So first of all, find out the total entropy change for the system. This is kilojoule per kg Kelvin multiplied by the mass. So it is 10 multiplied by 0.1. That is equal to 1 kilojoule per Kelvin, isn't it? Sorry, multiplied by 100. So it will be 10 kilojoule per Kelvin. So the entropy of the surrounding decreases from 80 to 75. So 75 minus 80, that is minus 5 kilojoule per Kelvin. It is minus 5 kilojoule per Kelvin. Isn't it? So change in entropy of the surrounding is minus 5. Change in entropy of the system is 10. So what is the change in entropy for the universe? That is equal to entropy generation. That is change in entropy for the system plus change in entropy for the surrounding. Change in entropy of the system is plus 10 minus 5. So it will be plus 5 kilojoule per Kelvin. It will be S generation is plus 5. Because we are getting entropy generation as positive, it means the process undergone by the system is reversible process. The process is irreversible. Yes, the process will be irreversible. B is the correct answer. Isn't it B? B for Bombay will be the right answer for this given question. Now, entropy change for a reservoir, if we find out the entropy change for a reservoir or fluid undergoing a phase change, it means temperature remains constant. Let me call it as T naught. So in that case, the entropy change for a reservoir is Q by T naught. If it is a reservoir or when it is a fluid undergoing a phase change, the entropy change will be Q by T naught, joule per Kelvin. So for a finite body, entropy change for a finite body or fluid undergoing a temperature change. So temperature will not be constant here. Temperature will not be constant. For a finite body, temperature will not be constant. If the temperature will not be constant, then we can say change in entropy is equal to M into C into ln of Tf by Ti, joule per Kelvin. We have integrated. So Ti and Tf are initial and final temperature. Initial and final temperature respectively. Initial and final temperature respectively. They are initial and final temperature respectively. Is this clear? And M is the mass of the system. C is the specific heat of the system. M is the mass, C is the specific heat. For an ideal gas, it is again important. Entropy change for an ideal gas. Specific entropy delta S is equal to Cv ln of T2 by T1 plus R ln of V2 by V1. It is in terms of temperature and volume. The unit is joule per kg Kelvin. So delta S in case of Cp ln of T2 by T1 minus R ln of P2 by P1. It is in terms of temperature and pressure, and delta S is equal to Cp ln of V2 by V1 minus plus Cv ln of P2 by P1. It is as a function of pressure and volume, specific volume. The unit of each and every expression is joule per kg Kelvin because they are specific entropy change. These are the expression for an ideal gas system, whether it is undergoing a reversible process or irreversible process. Reversible or irreversible process. These expressions are again very important expression. These expressions are also very important expression, and if T1 is equal to T2 or U1 is equal to U2 or H1 is equal to H2, because U and H are function of temperature only in case of ideal gas, then delta S will be equal to R ln of V2 by V1 or equal to minus R ln of P2 by P1. This is the special case. This is the special case. We can find out the change in entropy joule per kg Kelvin for an ideal gas system. For an ideal gas system, if T1 is equal to T2 or U1 is equal to U2 or H1 is equal to H2. And now the last part is entropy balance equation. Entropy balance equation or entropy. So we can say change in entropy of the system is equal to entropy transfer. How the entropy transfer take place plus entropy generation. This is the expression for entropy balance. This is the expression of entropy balance, because entropy is a non-conserved property. There is a generation of entropy through the irreversibility associated with the process. So the total change in entropy of the system, the entropy transfer will take place along with the heat transfer and along with the mass transfer. The entropy transfer takes place along with heat and mass. There is no entropy transfer take place with the work transfer. Why entropy transfer will not take place along with the work transfer? Because the work is an organized form of energy. Because work is an organized form of energy, so it will not transfer any entropy. Work is an organized form of energy, that is why it will not transfer any entropy. And entropy generation is due to irreversible process. Irreversible process. It means for reversible process undergone by the system, S generation will be equal to 0. When the process is reversible, entropy generation will be 0. So for a closed system, if the system is a closed system, there is no mass transfer taking place, only heat transfer. So we can say entropy transfer is due to heat transfer, del Q by T 1 to 2 plus entropy generation is equal to S2 minus S1 of the system. This is the expression for a closed system. If we write per unit time, so del Q dot, if we write per unit time, this is joule per Kelvin. If we write per unit time, so this will be S dot generation is equal to ds by dt in the system. That is joule per Kelvin second or watt per second. This is watt per second. This is watt per second. कौन सा? नहीं, ये साइकिल नहीं, ये प्रोसेस के. दिस इज फॉर द प्रोसेस. साइकिल के लिए तो एंट्रोपी चेंज 0 होगा ना. फॉर ए साइकिल चेंज इन एंट्रोपी विल बी 0 because entropy is the property. For a thermodynamic cycle, we are talking about a process. Others, these are for the process. A closed system undergoing a process. For a reversible process, इरिवर्सिबल प्रोसेस है, रिवर्सिबल प्रोसेस होता तो एस जनरेशन 0 हो जाता. So this is the expression for a closed system undergoing an irreversible process. And if the system is in steady state, for a steady state system, ये already लिखा हुआ था, for a steady state system, for a steady state system, so we can say ds by dt is equal to 0. So the expression will be del q by t dot plus s dot generation is equal to 0. This is the expression for a steady state system. For an open system, if we talk about open system, for an open system undergoing irreversible process, let us say, for an open system, so the entropy transfer will take place along with the heat transfer. Entropy transfer will take place along with the mass transfer, MISI minus MESE. Then entropy transfer will, entropy generation will take place. Then entropy generation is equal to change in entropy of the control volume, that is S2 minus S1 in the control volume. If we want to write per unit time, this is for open system. This is along with the mass transfer. This is along with the heat transfer, and this is due to irreversible process. So this, the left hand side is entropy transfer plus entropy generation, and right hand side is the change in entropy. The unit is joule per Kelvin. If we write per unit time, then the expression will be integration of del q dot by t plus m dot I Si minus m dot E Se. S is the specific entropy. Small s is the specific entropy because mass is taken separately. Specific entropy. So m dot I Si minus m dot Se plus entropy dot generation is equal to ds by dt in the control volume. The unit is equal to watt per Kelvin, joule per Kelvin per second. And if it is a steady flow process, the final words. So if it is a steady flow process, then we can say ds by dt in the control volume will be 0. So our expression is del q by t plus mass flow rate will also be constant. For a steady flow process. So m dot into Si minus Se plus S dot generation is equal to 0. If it is the reversible process, then S generation will become 0, right? If it is adiabatic process, then we can say Q will be equal to 0, or we can say integration of del Q by T will become 0. Is this clear? So that is how you can have the expression for entropy balance. These are the expression for the entropy balance. So this is all about the entropy change. There is a question on the screen. Can you quickly solve the question? Everyone, please give it a try. So I will be about to finish in next 2 minutes. Everyone, please do let me know your answer. Give me the answer for this one. I will share the PDF of this session to my Telegram channel. Okay, so you can have a revision. I hope you understood the concept energy balance, entropy balance, and in between them the first law and second law of thermodynamics. What is the answer? A system is undergoing a state change from 1 to 2. According to the second law of thermodynamics, for the process to be feasible or possible, the entropy change of the system, what is the answer? Entropy change of the system. there is no condition for the entropy change for the system. There is no condition for the entropy change for the system. It can be positive, it can be negative, it can be zero. What is the condition on entropy change for the universe should always be greater than zero. That is the condition. Entropy change for the universe should always be greater than zero. So entropy change for the universe, that is equal to entropy generation, is equal to zero for reversible process, and entropy change for the universe, that is entropy generation, is greater than zero for irreversible process, right? So entropy change for the system can be greater than, can be less than zero. There is one more question on the screen. Another question on the screen. Let me know the answer. 1 kilogram of water at room temperature is brought into contact with a high temperature thermal reservoir. The entropy change for the universe is heat transfer is always irreversible process. Only isothermal heat transfer is reversible process. Heat transfer is always irreversible process. Isothermal heat transfer is called as reversible process. Isothermal heat transfer, which is there in Carnot cycle, is a reversible process. Isothermal heat transfer is a reversible process. So entropy change for the universe, because it is irreversible process, so entropy change for the universe is always positive. It will always be positive. Why you are saying entropy change will be A? It will not be A. Entropy change 1 kilogram of water at room temperature. Let me call it as room temperature T0, and the initial temperature of water is T1. So we can say entropy change for the system will be, entropy change for the system is equal to MC into ln of T0 by T1, and delta S for the surrounding is equal to MC T1 minus T0 upon MC delta T upon T0. So system and surrounding will not have the same entropy change. System and surrounding will not have the same entropy change. They are not equal. First one is negative. Change in entropy of the system is negative. This is positive. So the entropy change for the universe must be positive, right? It should always be positive. So that completes my discussion. I hope you guys enjoyed this. There is a series which is going to start very soon for ESE previous year questions on your YouTube channel, starting from 21 to 23. Starting from 18th of August, right? So thank you for joining in, guys, and thank you for staying. You can join our paid courses also, which are running, where we are completing the entire syllabus in detail and in an organized manner. So it will help you to boost up your preparation, and it will help you to get the maximum score in your upcoming GATE, ISRO and other competitive examination. So you can always connect with me through the mail ID if you want to discuss anything, and it is always preferred to join me on the Telegram, so that we will be sharing all the important information through the Telegram channel only. All right. And there are some other series which are running on BYJU'S YouTube channel, Sunday Ka Funda and Super Saturdays. So with this note, let me take your leave. Thank you, guys. Thank you very much. Stay safe, stay motivated, and keep preparing with your full dedication and hard work. Today at 6 p.m. I will be coming live on the BYJU'S app, free app class. And here we are discussing fluid mechanics mock test. Today's session is about kinematics of the fluid flow. So if you have time, you can join me for the fluid kinematics mock test on the BYJU'S app at sharp at 6 p.m. All right. And tomorrow at 11 a.m. Tomorrow at 8 p.m. in the night, I will be coming up with the MSQ series for heat transfer. So that is all from my side. Thank you very much, and Jai Hind.